Reddy. So I'm going to teach you now trigonometry. So first let us learn the meaning of the word trigonometry. So the word trigonometry is made up of three words. That's going to be trigonometry. Tri means three and gono means angle and metry means to measure. So it's literally means that three angle measure means it's gonna be entirely related to the triangles where it has three angles in it. So the measurement of these three angles and the relation between the angles and the sides of the triangle are dealt in trigonometry. So trigonometry is a branch of mathematics where it deals with the relations between the angles and the sides of the triangle, particularly right angle triangles. Why we are learning more about right angle triangles is so any triangle, whether it may be acute or an obtuse angle triangle, it may be divided into two right angles by an altitude. So an altitude is a line drawn from the vertex of the triangle to the opposite side where where this line makes an 90 degrees with the opposite side. So it's called an altitude. So any triangle can be divided into two right angles. So right angle has some special properties like Pythagoras theorem, and it has standard 90 degrees angle, and we could easily study right angle triangles rather than acute and obtuse. So any triangle can be divided into right angle triangles. So we are going to mainly focus on right angle triangles in trigonometry. So what we are going to learn today is basic trigonometric ratios, their angles and their values of those ratios in different angles, and trigonometric identities derivation and these values, and the rule of complementarity. Okay, so we're going to learn this. So first we need to name the right angle triangle. Triangle A, B, C. So in this triangle, it's going to be 90 degrees at the vertex B, and so I want to teach one property for you, that is the smaller angle in a triangle, the smaller angle faces the smaller side, the larger angle faces the larger side. Similarly, the larger side faces the larger angle, and the smaller side faces the smaller angle. Okay, so it's the properties of any triangle you see. So in right angle triangle we have the 90 degrees angle, which is the largest angle, this triangle. So always the 90 degrees angle opposite side, it faces an side which is the longest side, and this longest side is called as the hypotenuse. So after that, depending upon, and the angle is measured in, angle is a measure of distance between any two line segments or rays. So it is a measure between the distance. Steepness is measured in this angle. So measurement of angles are in many ways, but the most common way to measure is in degrees. So what is 1 degree means when we divide a circle into 360 equal parts. So this one equal part is said to be a 1 degree. Okay, like this 360 degrees. There are many ways to measure, but most common is degrees. And the abbreviation used to denote an angle is represented as theta. Is the symbol of theta. So now we're going to learn the name of other two sides for right angle triangle. So depending upon our choice as preference or choice as theta, if this is going to be the theta for angle, so then the side facing the opposite to this theta is said to be the opposite side, and the side which is adjacent, which is just to this theta, is called, other than the hypotenuse, called adjacent side. So, and whether if we change our preference of theta like this, then BC would be the opposite and AB would be the adjacent, and hypotenuse would be the same as the opposite of the longest angle. Hypotenuse starting with the longest side, it doesn't change. So this is going to be the opposite and this is going to be the adjacent side. So now we're going to learn about the trigonometric ratios. So there are 6 trigonometric ratios, out of which 3 are proper and other 3 are reciprocals of the 3 trigonometric ratios. So first 3 are sine theta or SINE, but it's written as sine theta. It's gonna be the ratio of opposite and to opposite to the hypotenuse. It's gonna be opposite to hypotenuse. It's gonna be AB by AC in this case. And other trigonometric ratio is cosine or cos theta. It's gonna be written as adjacent by hypotenuse. It's going to be the ratio of BC to AC. And other ratio is tangent theta or tan theta. It's going to be the ratio of sine and cosine. It's going to be sine theta by cos. It's going to be opposite by hypotenuse by opposite, adjacent by hypotenuse. It's going to be opposite by adjacent. It's going to be AB by BC. So these are the 3 proper trigonometric ratios, and the other 3 are inverse of these trigonometric ratios, that are cosecant theta or cosec theta is a inverse of it's a reciprocal of sine theta. It's gonna be hypotenuse by opposite. It's gonna be AC by AB. Other is secant theta or sec theta. It's gonna be the inverse of cos theta or cosine. So it's gonna be hypotenuse by adjacent. It's gonna be AC by BC. And similarly, cotangent theta or cot theta, it's gonna be the reciprocal of tangent theta or tan theta. It's gonna be adjacent by opposite. It's going to be BC by AB. Okay, these are the other reciprocal trigonometric ratios. After learning about the trigonometric ratios, we're going to learn about the trigonometric identities. There are three trigonometric identities. I'm going to teach their derivation now. So after that I will be teaching about the values derivation and different angles. So the three trigonometric ratios are derived from the Pythagoras theorem. So what does the Pythagoras theorem say here? AC square or hypotenuse square is the sum of other two side square. It's going to be the opposites, AB square plus BC square adjacent side. So it's going to be the Pythagoras theorem. So from this Pythagoras theorem, there are going to be three trigonometric identities which are very important. There are, first, when we divide this equation, whole equation with the AC square, we get AC square by AC square is equals to AB square by AC square plus BC square plus S by AC square. So upon doing this, we get one here, AB square by AC square, opposite by adjacent. It's going to be the sine square theta plus BC square by AC square, adjacent by hypotenuse. It's going to be the cosine square, cos square theta. So the first trigonometric identity is sine square theta plus cos square theta equals to 1. So it's going to be the first trigonometric ratio. And after that, when first we are divided with AC, now let's divide it with AB. So AC square by AB square is equals to AB square by AB square plus BC square by AB square. So after getting cancelled, AC square by AB square, AC square plus by AB square, it's gonna be cosecant square theta equals to 1 plus BC square by AB square, adjacent by opposite. It's going to be inverse of tan. So it's going to be cotangent. It's going to be cot square theta. So other trigonometric ratio, cosecant square theta equals to 1 plus cot square theta. So we are divided with AC and AB. Now we are going to be dividing with BC square. Now AC square by BC square equals AB square by BC square plus BC square by BC square. So it's going to be 1 AB square plus BC square and AC square by BC square. It's going to be AC by BC, hypotenuse by adjacent. It's going to be secant square theta. It's going to be inverse of cos. So it's going to be secant square theta. Sec square theta equals to AB by BC. AB by BC. It's going to be tan, opposite by adjacent. It's going to be tangent theta. So it's going to be tan square theta. It's just like third trigonometric identity. So it's actually second and it's going to be third, but no problem. These are the derivation of three trigonometric identities. It's going to be derived from the Pythagoras theorem. You need to remember actually these three: 1 plus tan square theta equals to secant square theta, 1 plus cos square theta equals to cosecant square theta. But these, if you forget, just divide it with any of these three and you will get all these three equations. Sin square theta plus cos square theta equals to 1. It's going to be anywhere remembered by you. So after that, trigonometric identities are completed. So after that, let me derive the values of different angles of different trigonometric ratios. So sin theta cos theta 0. Wait, first I'm going to take one factor 0, 30, 45, 60 and 90 degrees and 180 also, 120 also. These are gonna be set to as standard angles. So we're gonna know the values of the standard angles at different trigonometric ratios. So now 0 and 90 will be dealt at last. So first we need to we will learn about this and this. I will be explaining about 0 and 90 at the last. So first let us find out the values of 30 and 60 in all the trigonometry, all the ratios. First I will be telling about sin and cos. If we find sin and cos, then we could find tan as sin by cos. And other thing would be cosecant would be 1 by sin, secant would be 1 by cos, and cotangent will be 1 by tan. So we find sin and cos will be easy for us. So let me find the values of sin and cos. So for finding 30 and 60 degrees, so we need to take an equilateral triangle. So whose angle is 60, 60, 60. It's going to be of 60. So what I am doing is I'm drawing a line which is acting as a perpendicular bisector or an altitude which would divide these angles into 2 equal halves, and it also acts as a median which would divide this line as into 2 equal parts. So it's an altitude, it's a perpendicular bisector, and it's a median. In equilateral triangle, this line coincides with all the 3. So after that, for this, let me name the side line as A. It's going to be this entire would be A, but it's still as it's a median, A by 2, A by 2. Okay. So by applying the Pythagoras theorem, let us measure this length of this line for O. I am going to name this as A, B, C and D. So let us measure the length of AD. So as it's a 90 degrees and it's a hypotenuse, so A square equals to A by 2 whole square plus, let my name as x square. So A square equals to A square by 4 plus x square. So A square minus A square by 4 equals to x square. 4A square minus A square by 4 equals to x square. 3A square by 4 equals to x square. So upon doing this, root 3A square by x square. X square, A square would cancel this root, and it's going to be root 3A by 2. 4 is written as 2 square, no? So it's going to be 2 square. Root 3A by 2. The length of this side x is root 3A by 2. Okay? After finding this length, now we're going to apply the ratio. As what's sine 30? It's going to be opposite by hypotenuse. In case it's 30 degrees here, so let us take opposite as A by 2 and hypotenuse as A. It's going to be 1 by 2. So sine 30 is 1 by 2. And similarly, sine 60, when we take sine 60, this is going to be the opposite side. It's going to be root 3A by 2 by hypotenuse. It's going to be A. It's going to be root 3 by 2. So root 3 by 2. Okay. The cos would be inverse. So when we take cos 60, it's going to be reverse of the sine. So when we take cos 60, then this would be the adjacent side for cos. So A by 2 by hypotenuse, adjacent by hypotenuse. So it's going to be 1. So cos 60 is 1 by 2. And similarly cos 30 is root 3 by 2. As this is the adjacent, root 3 A by 2. This is the adjacent side and hypotenuse is A. So cos 30 is root 3 A by 2. Root 3 by 2. So after that, now tan 60, tan 30 will also will find like 1/2 by root 3 by 2. It's going to be 1 by root 3. Tan 30 is 1 by root 3. And tan 60 is root 3. Simply you could say. So 1 by 2 tan root 3. So it's going to be root 3. So if we inverse all this, we could get. So not need of tan now. Let's find sine and cos. So after 30 and 60, let us derive for 45. So for 45 degrees, we need a right angle isosceles triangle. So it doesn't look like a triangle. So for right angle isosceles triangle, the two sides would be equal, A, B, C, and this is 90. I actually said in the beginning of the class, I actually said a fact that the larger angle faces the larger angle, and the larger side faces the smaller side faces the smaller angle. Since these two angles are equal, and this is 90, the sum must be 180. So these two must be equal. So in order these two must be equal, the sum must be 90. So 90 by 2 is the angle. We could simply say that this angle is 45 degrees by basic geometry. So after saying this, so as AB and BC are equal, so whether you consider this as theta and this as theta, it doesn't have any problem because AB is A and BC is also A. If it's AB is A, BC is also A. So sine 45 is opposite by hypotenuse. So hypotenuse is x square equals to a square plus a square. It's going to be 2a square. X equals to root 2a. It's going to be root 2a. So now sine 45 is opposite. That's going to be a by root 2a. It's going to be hypotenuse. So it's going to be 1 by root 2. Similarly, cos 45, it's going to be a by root 2a. Similarly, 1 by root 2. So tan 45 is a by a, it's going to be 1. So both the values of sine and cosine in 45 degrees is 1 by root 2 and 1 by root 2. There's actually a trick to easily write all these values. So after 30, 45 and 60, let us now learn about 0 and 90. So let me tell sine 0 first. It is easy. Let me tell cos 0 after sine. So first sine 0. So how does 0 angle look like? So this is the hypotenuse. Wait. This is the base part, isn't it? This is the 90 degrees other side, and this is the hypotenuse. So when we keep on decreasing the angle, what happens? The opposite side reduces. So for 0 angle, the hypotenuse and the adjacent side coincides each other. and there is no opposite side left. Opposite is 0 at 0 angle. Just coincide. So sine 0 is going to be opposite by hypotenuse. How much it may be, we don't know. Maybe infinite. So it's 0. So 0 by anything is going to be 0. So sine 0 is 0. And cos 0 is when these two lines, when this line coincides with the hypotenuse coincides with the adjacent. So it's going to be, they are going to be equal. So cos cosine 0, cos 0 is 1. So similarly 90 degrees. Sine 90 going to be like this. So when we keep on increasing the angle, then for sine 90 degrees we need to keep on increasing the angle of hypotenuse and the adjacent side. So we keep on increasing this like this. So when we kept this at 90 degrees, this won't intersect this. The both lines would be the parallel. They would be parallel to each other when this is going to be 90 degrees. So what's the definition of sine? It's going to be the opposite to hypotenuse. So they're going to be parallel. They're infinite. They're equal. So it's going to be 1. Sine 90 is 1. And cos, there is infinite of hypotenuse and there is some limited of cos, adjacent side. So it's going to be very small under this infinite line of infinite length of hypotenuse. So cos 0, very small. It's nearly to 0. So 0 divided by anything. So it's going to be 0. So it's going to be 0. Okay. Remember, notice that sine value kept on increasing when the angle is increasing, and cos value kept on decreasing. And the maximum value of sine is 1, and the minimum value is -1, which is going to be unknown. It's not necessary for you now. So maximum value of cos is also 1 and minimum value of cos is also 1. Whereas in tangent you get infinity like that. Tan 90 is infinity because sine by cos 1 by 0. Anything by 0 is infinity. Undependent. So after learning this, we will learn a rule that it's going to be the complementary rule of trigonometric ratios. That is so if we take this as theta and this is the 90 degrees off, so in order to have this three angles as to sum of 180, so theta plus 90 plus this is going to be x is equals to 180, then theta plus x is equals to 90, x equals to 90 minus theta. So it's going to be 90 minus theta. Okay. Actually, I'm going to teach that trick of all silver teacups, but it's the demo, so I'm going to teach only about this complementary rule. So after this, we are getting 90 minus theta as another angle. Actually, these two angles are complementary. The sum must be 90. So 90 minus theta plus theta is going to be 90. Plus this is going to cancel now. It's going to be 90. So these are complementary angles in order to have a sum of 180. So after that, sine theta is equals to AB by AC and cos theta is BC by AC. So after this, when we have sine of 90 minus theta, it's going to be written as, this is the opposite side for this. So it's going to be written as BC by AC. It's similar as cos. BC by AC is cos. So it's going to be cos theta. So sine 90 minus theta is cos theta. So similarly, cos of 90 minus theta. For this is the adjacent side. AB is the adjacent. AB by AC. So AB by AC is sin theta also. So cos of 90 minus theta is sin theta. Okay. This is the rule of complementary. Okay, it's gonna go. So what we have learned is definition of trigonometry, why we studied like right angle triangles in trigonometry, and after that different trigonometric ratios, their values, derivation of these values at different angles at 60, 30, 45, 0 and 90. After that, identities and the rule of complementary. These are four are going to be learned today. So thank you for this demo.